Hi and welcome to this tutorial. We've covered the relationships between entities, the one-to-one, one-to-many, and many-to-one, and many-to-many in our previous few tutorials. In this tutorial, we're going to look at a few concepts that are common across most of these relationships. And we'll cover a lot of concepts. These are the miscellaneous concepts which kind of fit at different places. So just wanted to take a separate tutorial and cover some of these concepts here. So okay, let's go. So the first one is the first one that I want to cover is this annotation here. Let's take this example. Say I have a many-to-many here, and let's assume this was a one-to-many. Or let's take the vehicle object and take this as a many-to-one, say. Okay, I'm going to remove this. Now, and this would be a private user details user. Okay, now assume that this car is not, this vehicle is not having an owner. Okay, they don't, I mean, this vehicle is not yet rented or not yet purchased, so there is no user for this vehicle. So now what would happen if you had a many-to-one association here and say you had the getters and setters for get user and set user. Now imagine if your code would get the vehicle and try to do a get user and there was no association for this vehicle in the user mapping, say there was no user for this vehicle, then Hibernate would throw an exception. It would say, hey, I don't have a user for this vehicle, so a get user for a vehicle object which does not have a user would throw an exception. So there is a way we can suppress this exception so that it does not, Hibernate does not come up with an error every time there the data is not there. And if it's a common situation for the data not to be present at any point of time, then you can prevent all these exception errors coming up by using an annotation here called at not found. Okay, so what I'm doing is I'm saying if this is not found, if the user is not found, then what to do? Okay, so if I import this, you can see this is a org.hibernate.annotations. So this is not a JPA standard. This is a feature that Hibernate provides, but I have found this very handy, especially if you're working on old systems where you didn't actually have data from the scratch supplied by Hibernate. It was some legacy data and you might not have all the relationships available. So in that case, what you do is you can use this at not found annotation to handle situations where there is no such relationship available. So what you can do is at not found, you will have to give what is called as an action property. So if the the relationship is not found, then what you need to do, you need to do this action equals, there is a not found action enumeration dot ignore. So not found action has this ignore enumeration. So what happens is if your user is not found, then you're telling Hibernate to just ignore it, not throw an exception. So this is something that I found very handy and just wanted to throw this concept in there so that if you feel that you might come across such not found exceptions and you want to handle it gracefully, this is one way you can actually handle that. Okay, the next thing that we're going to talk about are the collection objects that Hibernate supports. So Hibernate has its own internal data types that it maps to for the collection objects that you're creating, and there are a few semantics for collections that are available in Hibernate. So the first semantic is the bag semantic. Hibernate has a bag kind of a collection object that it supports. So what a bag means is it doesn't, it's similar to a real life bag. It doesn't matter how you put things inside it. You can put things into a bag in any order. You can retrieve it in any order. So that is a bag semantic that Hibernate supports. So you can implement a bag semantic by using either a list or an array list. And similar to a bag, we also have a bag with an ID. Again, this is something that we can use with a list or an array list. So a list or an array list will have an index property. So what you're doing is you can pull up items depending on the ID that you're supplying. So the next one is a list semantic. So this is again a list or an array list. It's the same thing. The only difference that is applicable from a list or a bag is that a list can be ordered. You can have a sorted list, whereas a bag, it really doesn't matter which order in which you get the data. The next one is a set semantic. We've seen a set. This is similar to a set data type in Java, so I'm not going to go into much details. And then finally a map. Again, this is similar to a map data type of Java. Okay, you don't have to actually worry about the semantics. What usually happens is you'll be working on one of these data types here. You'll probably have a list of objects, or a set of objects, or a map of objects. So what's happening is Hibernate is using one of these semantics behind the scenes in order to maintain the collection. Okay, so the final thing that I want to talk about is something called as a cascade. This is applicable to all the relationships, be it one-to-one, one-to-many, many-to-one, or many-to-many. So we'll have a look at what cascade means here. Let me just undo the changes that I've done. Okay, and I'll save this. And user details, yeah, we haven't modified this. So yeah, what does cascade mean? Say, for example, I have this, this program where I have a user, and let's say this user has 10 vehicles or something like that. So I will have all the 10 vehicle objects, and I will assign those vehicle objects to the user. So now if I have to save the user, so what I'd have to do is I'd have to first do a session.save of user, and I'll have to do a session.save of all the vehicles of the user. Say I have 10 vehicles or 50 vehicles. Saving all of them is going to make the code look messy, and it's also a pain. So it's not just for saving. Say for example you delete the user, and you want to go ahead and delete all the vehicles associated with the user. We haven't seen how to delete a value. We'll have a look at that subsequently, but you should note that whatever operation you're doing for the user, you will have to do all the operations, you'll have to do the same operation for all the vehicles. So a save or an update or a creation will affect all the vehicles, so you'll have to pass all these vehicle objects to a session.save. So there is a way to avoid this, and you can use something called as a cascade. So I have the user details class and the vehicle class here. This is the same two classes that we've been looking at in the previous tutorials. The change that I've made in the user details classes, I've changed it to a one-to-many. This was a many-to-many, at the end of our previous tutorial. So I've changed this to one-to-many, and I have a vehicle collection inside the user object. And in the vehicle, there's no backwards reference. There's no inverse reference. From the vehicle, you cannot go to a user. It's just from the user to the vehicle. So this is a one-to-many relationship, which is a classic scenario to study the cascading that we are about to learn. So we have this vehicle collection. I've implemented an array list here. Now, what I want to do is, when I want to create, here is our the test class that we run. We have a user object here, and we have two vehicle objects. So we assign the vehicles to this user. So car and Jeep are the two vehicles that have been assigned to the vehicle collection in the user. So this collection here will have two values, which are the two vehicles, car and Jeep. Now when I save this, I am saving the user, the vehicle 1 and vehicle 2, which is the car object as well as the Jeep object. So what happens if I just save the user? Isn't that enough? Let's remove these two lines. So the user has a reference to both the car object and the Jeep object, but I'm not explicitly saving the car object and the Jeep object. Now what happens if I run this? Let's save and run. Let's see what happens. So here you can see there's an exception that says object references an unsaved transient instance. So it's asking us to save the transient instance before flushing. So what this is saying is you have an object that you're trying to save, but this object references another object that you have not saved. So we need to make sure that those objects are saved as well. So this is the problem. Why does Hibernate not automatically save it? We know that this user has two references. One is a vehicle and a vehicle 2, which is the car and the Jeep objects. Now why does Hibernate not save it directly? That's because these are also entities. This vehicle is an entity. This vehicle is again another entity. Now Hibernate cannot make that assumption and save the entity, because that might be something that you would want to do differently. Sometimes you wouldn't want to save these entities automatically. You would want to have control over it. Now if it were a collection object, let's say this weren't an entity, it was just a value type, then this vehicle the whole purpose of this vehicle would be for this user. So it makes sense, when the user is saved, you save that vehicle also. But since it's not a value type, it's an entity, these two vehicles have a life of its own. It's not really bound by the user. So you wouldn't want an automatic save or an automatic any operation to happen. So that's the reason why Hibernate gives this the benefit of the doubt, and then it does not do any automatic saving. It wants us to specify when and how this needs to be saved. So which is fine. We did this earlier. So what we did was we did a session.save of both the vehicles. Now the problem is, if you have a huge list of objects here, you would have to do a session.save of all of them, and that's a pain. So that's what we're going to avoid by using the cascade. So what I do is, in the user details, wherever I have this reference, I'm saying this is a one-to-many relationship with the vehicle. So here I will have to tell Hibernate saying, hey, I do not want to save each and every object here. If you come across this collection and you have unsaved objects, when I'm doing a save for this user class, go ahead and save all the objects in this collection as well. So that's what I want to say, and I say that using the cascade. So the one-to-many annotation has a property called cascade equals, and again there is an enumeration that supplies the values. So I have cascade type dot. Okay, so here you see there are a few options. You have detach, merge, persist, refresh, and remove. We will look at all the other things later, but right now we want the cascading to happen on save. When you want to save the user, it has to save the corresponding vehicle instances. So I will have to select this persist. So persist tells Hibernate that if you see any new entities inside this the vehicle collection which has not been saved, when the user is being saved, go ahead and save them as well. So this is what the cascade.persist means. Okay, now we are actually all set to run this, but there is one other small change that we'll have to make. I'll make the change now, and we'll learn a bit more about this in the later tutorials. So here, where we have a session.save, instead of a .save, I will call another method of the session, which is persist. Now a persist kind of does the same thing as what a save does, but there are a few differences, and this is something that we'll explore in the upcoming tutorials. But for now, just make this change. This change, session.persist, ties in with this change that we have made to cascade persist. So whenever a persist happens, a cascade needs to happen. So that's what we are doing here. We are saying, hey Hibernate, persist this collection when you are persisting this entity, and when we are actually saving this, we are calling a session.persist. That ensures that this user is persisted. So again, we will look at the difference between persist and save later on, but for now let's make this change and save and run this. Now there you go, you do not see that error anymore, and even though we are not saving the vehicle objects, it is inserting values into the vehicle, and it's also inserting the mappings. So this cascade type.persist is one of the different cascade types. Now you can have a cascade type dot remove, which does a cascade for delete operations, and again merge and detach are things that we're going to explore later when we look at the life cycle of entity objects. That's when we're going to learn a bit more about persist and refresh as well. And the final thing is, if you want all persistence to happen, everything to happen cascaded, all operations need to be cascaded, whether it's a creation or a deletion or updating, anything like that. If you want all these to apply, then you can choose a cascade type dot all. So what this makes sure is that instead of specifying each and every individual operation, you say cascade everything. So no matter what happens to the user entity, the same thing gets propagated to the vehicle entities as well. So the cascade type dot all is kind of like a shortcut so that you don't have to enter all the individual cascade types.